Saxon Algebra 1/2, Lesson 17. Students, our topic today is areas of rectangles. This is a great review topic. We're going to be building on it in the future. We talked about perimeter. And perimeter measures length, right? When we are talking about the perimeter of a shape, we're talking about the distance around the outside, which can be measured with like a piece of string. That's a helpful image, is to think, okay, I've got a piece of string and I'm stretching it around the outside of my book, for example. How long is that piece of string going to be when I go all the way around? All right, when we're talking about area, oh, one thing, this is one dimension, not one direction, one dimension. One direction is a whole different thing. But area, this isn't helpful. It measures the area, or we can think of it, it measures length times width. And it gives us a two-dimensional answer. Let's look at a simple example. 1, 2, 3, 4, 5, 6. Okay. I'm going to imagine a rectangle that is 6 units by 4 units. We can say feet, inches, centimeter, whatever unit you'd like. I'm just going to put the number there. And that tells us that this side is 6 units long and this side is 4 units long. We can imagine area as asking ourselves how many 1 unit little squares, kind of like Duplos, right? Like this is like the base plate. And if we want to fill this up with square pieces that are 1 unit by 1 unit, how many would we be able to fit onto this base plate, right? Well, we'd have 4 going this way and we'd have 6 going this way. And if you add those up, 6, 12, 18, 24, then you find out that 6 times 4 means that it's 24, let's just call them, let's just say feet, just to make it interesting. This is 24 square feet, which we can write like that, which technically we're saying feet squared, but it's fine, it's the same way. Or we can write 24 square feet. Either one of these is a perfectly fine way to write the answer. I personally vote for that style because it's so much faster. So the area of a rectangle equals, let me just write this out. This is length times width. But when you write it in the cover of your book, you can just write this as the abbreviation. The area of a rectangle equals length times width. Remember that it's a really great idea to go to the back or the front cover of your book and use this space for your formulas. So I'm going to write it here. Area of a rectangle equals length times width. If you don't remember what L times W is, you better write that out. Go ahead and do it right now. Front cover's fine, but I've got the kind of notebook where the front cover is made, oh no, this one's fine. Sometimes my front covers are kind of plastic and then the back cover is cardboard. So you can use the inside of the back cover or the outside to write your formulas. Some students say, oh no, but I probably am gonna fill this book up and then I'll have to get a new notebook for my homework. And all my formulas will be gone. And I say, no, when you get to the end of this one and you're starting a new one, just take your old book and copy all your formulas into the new book and you'll be fine. Okay, so length times width. Example 17.1. How many 1-inch square tiles would it take to cover this figure? And then they give us a nice little rectangle here that says 36 inches by 24 inches. Now, remember that saying how many 1-inch square tiles is just another way of thinking about area, right? We don't want to draw out 36 by 24. That would be too much of a headache. So we just remember our formula. We multiply 36 times 24. I'm going to write them this way so I can multiply them instead of writing them side by side. Some students say, they ask me a really good question. Which dimension is the length and which one is the width? Here's the spoilers, you guys. It doesn't really matter which you call which, as long as you take one from the short side and one from the long side, right? You wouldn't want to take both from the short side or both from the long side, as long as you get one and the other. Typically, the length refers to the longer side and the width refers to the shorter side, but that's not 100% ironclad. So just remember, it doesn't really matter as long as you get the two different sides. Okay, let's multiply. Please multiply. Don't just watch me multiply it yourself. I'll multiply quietly and then we'll compare our answers. Because of the way John asked this question, how many tiles, how many 1-inch square tiles would it take to cover the figure? We're going to write our answer as that many tiles. If you wrote it this way and said 864 inches squared, I would be fine like that. Or if you wrote out square inches, that would be fine too. But putting tiles is the most precise way to describe your answer, since John asked how many tiles would it take. Okay, we just have one more. Example 17.2. Find the area of this figure in square centimeters. Dimensions are in centimeters. All angles are right angles. Okay, so we have a picture that looks like this. Okay, I'm drawing the picture in my homework. That is super important. It helps you notice things. It is not a waste of your time. Yes, you can look in the book and see this same picture, but drawing it is a helpful part of solving the problem. So please take the time to draw the picture. Okay, all of this information in blue is given. Now, we're sitting here and we're saying, all right, we're supposed to find the area of this square. But how the heck are we going to do this, because this isn't a square? Well, we have two options. What we're going to do is we're going to take this shape and we're going to break it into two smaller, simpler shapes and then find the area of those. One way we could do that is to visually divide into two rectangles like this. We'll call this triangle A and we'll call this triangle B. Now we have to carefully find the length and width of each triangle. So for A, or I'm sorry, not triangle, rectangle. For A, the length, well, let's take this side first. This is the width, that's 4. Now we need the longer side. Now we have to be careful here. We go, oh, it's 6. But no, we've divided our triangle right here. We're not gonna count this part as part of triangle A. We're gonna count this as part of triangle B. So we need to choose 4 because that's the shorter length, and that reflects the dimensions of this rectangle. If I draw to help you see it better. All right, so that much is 16. And then rectangle B, okay, that's the whole thing, so that's 2 times 12. Notice that I'm writing the shorter dimension first and then the longer dimension, but I said in my formula that it's length times width. Well, just remember, when you multiply, order doesn't matter. So as long as you're getting the two different sides, you're fine. This is 24. And so my total is 40. And then this problem has, what I like to do is when I'm writing down the problem, I like to write the unit over here and just circle it so that I'll remember, because you don't use it until you get to the end and then you need it. Centimeters squared. That's the right answer. Okay, now, when I first started doing these problems, problems, I was always like, wait a minute, I see a different way to do it. Why can't you do it this way? So I'm gonna redraw our original figure. And let me put all the numbers back on it. I circle the numbers sometimes to help me keep track of what line they're describing. It just helps me make sense of my diagram. All right, the other way we can approach this problem is, instead of conceiving of the two rectangles this way, we could divide it this way as well. So I'm going to call this rectangle C and this rectangle D. I have a feeling I've been saying triangle when I should be saying rectangle. If I don't catch myself and correct myself every time, just know that I'm just confused. We're not talking about triangles at all. This is all rectangle. Okay, so rectangle C, length times width again. I'll put that here just so we're clear. This one now is 4, look, the long side is 6. Now all this side is part of C. So I'm gonna say 6 times 4, that would be this 4, not that 4. This is the shorter side, this is the longer side. And so that's 24. And then D is 2 times, okay, now we need to know this side. We don't have it, we only have this long side. But I can compare these two. 12 is all of it, 4 is that much, so this must be 8. Tongue twister. So to get this rectangle, I multiply 2 times 8, and that's 16, and look, we get 40, and I'll write it underneath, centimeters squared. It's okay, you guys, this is a perfect example. That hole in my paper made it impossible for me to write that over to the side, so I just wrote it underneath. That's fine. Yay, that's also correct. Notice we get the same answer either way. So trust your instincts and divide the more complicated rectangle into 2 smaller rectangles, however your eye sees it, and you should be fine. All right, that is lesson 17. Let me just show you the practice. Okay, this one you'll have to divide into 2 rectangles. You can do it this way, or you can do it this way. But notice these 2 shapes, you'll be doing this one. These are gonna need to be divided into 3 rectangles, right? You could go across this way and have the little skinny bit and the bigger blob and then this long one at the bottom. Or you could divide them by extending this line down and this line down. So you would have 1, 2, 3 rectangles standing next to each other like skyscrapers. Either way is fine. Either way will get you the right answer. Just be aware that on our example, we only had to divide it into 2 chunks, and these problems will require you to do 3. All right, that's the end of 72. Yay! Great job, you guys. I will see you next time.